Have you ever walked into an old cathedral and been completely mesmerized by the light streaming through its stained glass windows? It feels like magic, doesn't it? But what if I told you it's not magic, but a beautiful dance of art and science? Today, we're going to uncover the hidden physics behind these incredible works of art.
Behind every moment lies a scientific wonder. I'm Kale, and welcome to SciCurios, where curiosity meets science.
Stained glass windows are essentially giant, intricate filters for sunlight. The secret to their brilliant colors lies in tiny metal particles mixed into the glass when it's molten hot. Think of it like adding a pinch of a special ingredient to a recipe. For example, adding cobalt creates those deep, rich blues. Copper gives us vibrant reds and greens. And believe it or not, tiny nanoparticles of gold are responsible for creating stunning ruby and cranberry hues. So how does this work? Sunlight, or white light, is actually a mix of all the colors of the rainbow, like a full spectrum of wavelengths. When this light hits the stained glass, the metal particles inside the glass go to work. Each type of metal is picky. It absorbs certain wavelengths of light while letting others pass right through. A piece of blue glass is absorbing all the other colors, the reds, oranges, yellows, and only transmitting the blue wavelengths to your eyes. That's why the color appears so pure and intense. This phenomenon is called selective absorption and transmission. But it gets even cooler when we talk about gold. The nanoparticles of gold create color through a process called plasmon resonance. The electrons in the gold particles oscillate in response to the light waves, scattering specific colors while letting others pass. It's advanced physics happening in a centuries-old art form. But the color is only half the story. The texture of the glass and the dark lead lines that hold the pieces together also play a crucial role. The textured, uneven surfaces of the glass don't just let light pass through. They scatter it in 1,000 different directions. This scattering effect makes the light diffuse and soft, giving it that signature ethereal glow. It prevents harsh glares and fills the space with a gentle, colored ambiance. Then you have the lead cames, the black lines that outline each piece of colored glass. You might think they just hold the window together, but their function is also artistic and perceptual. These dark lines create sharp contrast against the bright colors. This contrast makes the colors pop even more, making them seem more vibrant and luminous than they would on their own. Our brains are wired to notice contrast, so the lead lines effectively frame each color, enhancing its impact and guiding our eyes through the story the window tells. So a stained glass window isn't just a pretty picture. It's a sophisticated optical instrument. It's a masterful combination of material science, where metal ions create color, optical physics, where light is filtered and scattered, and human perception, where contrast and composition bring the scene to life. The artists who created these windows might not have known the terms plasmon resonance or selective absorption, but they were true masters of light. They intuitively understood how to manipulate it to create an atmosphere of wonder and transcendence. Next time you see sunlight pouring through a stained glass window, take a moment to appreciate the science at play. You're not just looking at a piece of art. You're witnessing a beautiful experiment in optics, one that turns an entire building into a laboratory of light and color. It's a timeless reminder that art and science are two sides of the same coin, both striving to understand and capture the beauty of our world. Thanks for joining me on this deep dive into the science of stained glass. If you enjoyed this, be sure to like the video and subscribe for more explorations into the science behind everyday wonders. See you in the next one.
Science is everywhere if you just know where to look. Thanks for watching SciCurious. Until next time.